So sometimes we don't have a constraint, we just have one equation. So let's look at this. I know you've seen something like this in pre-calculus many, many times. So if I take a square piece of cardboard that's 24 by 24, okay, then I'm going to cut out squares out of the corners. So I'm going to take these squares out of the corners. Then I want to find what's going to maximize the volume, right? Volume that's maximized. So volume, whatever that equation is, I'm thinking that's what I want to take the derivative of and set it equal to 0, right? So you're getting that idea. So let's go find the volume equation. So volume is length times width times height. And so think about it. If I have this this square of x that's being folded up so that the height will be x, right? Because I'm folding up that corner. So you can think of this as a box top of like a printer box where there's just a not very deep it is. And so then I got to think about what the length and the width is, right? Because volume would be length times width times height. So let's think about this. If all of this is 24, then this right here would be 24 minus 2x. And the same thing. If all of this is 24, then this right here would be 24 minus 2x. So my volume would be x, which is the height, and length and width would be 24 minus 2x, and then I would square that. Okay, so we know we need to take the derivative of this and set it equal to 0. I would not recommend multiplying this one out. I would just go and do product rule. So first, d second. Okay, so you know how to take the derivative of this. You bring the 2 down, carry this along to the 1 power, and then you multiply by the derivative of the inside, plus second, 24 minus 2x squared, times 1, which is the d first. Okay, I'm setting this equal to 0, and I don't want you to multiply all this out. Think about what you could factor out. I think I can factor out a 24 minus 2x out of both of these terms. So if I factor out the 24 minus 2x out of this whole first term, then what's left is a -2, a 2, and an x, so negative 4x. Then if I factor out a 24 minus 2x out of this term, I'm left with a 24 minus 2x. Okay, so let's see what I've got. 0 is 24 minus 2x, and inside here I've got a 24 minus a 6x. There I have it. Two quantities multiplied together to equal 0. So 24 minus 2x is 0, 24 minus 6x is 0. So this gives me x is equal to 4. 24 equals 2x. This gives me x is equal to 12. So I did mention that there's going to only be one critical number. Here I have 2. So do both of these make sense? Think about it. Here I have a piece of cardboard, 24 by 24. Does it make sense to turn up corners for the x of 12? No, because I would have no box, right? If x was 12 and x was 12, there'd be no box there. So this is eliminated. And so this is our only x value that would work.